What's going on, Algebra Bros? It's Mr. C here, and in this video I'm going to discuss an operation that we can do with two functions that come straight out of Compton. I'm just messing with you about that part. But the operation is called composition, and let me just kind of um, build up to what this is. So in the past, what we've done was taken two functions, say f and g, and we've added them together. We've also subtracted two functions, multiplied two functions, and divided two functions. So we can perform all the ordinary operations of arithmetic with any two functions. But there's another operation that we can do called composition, which helps us to form a new function called a composition function, and it's denoted with a little open circle between the two function notations. So it's going to be denoted as something like f circle g. And how this operates is as follows. If we do or have this notation presented to us where it's f circle g of x, then what this is asking you to do is to take the function f of x and essentially plug g of x into it. And so we could write it in this alternative notation where it's f of g of x. So what this notation stands for, as well as the notation on the left-hand side of the equal sign, is plug g of x into f of x. So just a quick remark before I show you that we can do it in the other direction. We read the notation as f of g of x, and even though that phrase has a couple of instances of the word of, it does not mean multiplication. It means something entirely different. We're composing two functions in the sense that we're taking one function and plugging it into another function. There is a way to reverse the order to where you have something like g of f of x, which is what we're seeing next. And what this is asking us to do is to take the function g of x and this time plug f of x into it. So there's kind of an alternative notation to something like this. And what both of those notations stand for is plug f of x into g of x. I want to show you the whole idea of this and how you would operate with it if you had two particular functions and a specific value of x. So in this diagram, we're going to illustrate the idea behind function composition. And our function f of x that we're going to use here is 2x, and our function g of x is x minus 3. And a particular value of x that we're going to work with here is 5. So what we want to do in this example is find the composition f of g of 5. Now, how this works is going to feel a little backwards in the sense that the first function that we actually use here is the function g of x, even though it's written second in the notation. So check it out. We're going to take 5 as our input, and it's going to be put into the function g of x, which has the equation x minus 3. So if we plug 5 into g of x, we have to do 5 minus 3, which gives us an output of 2. Now if we were just figuring out g of 5, this would be our answer. But with composition, this output that we get from the function g of x becomes a new input. And what does it mean to call it a new input? Well, this output of 2 that we got from g of x is now going to get plugged into the function f of x, which is given by the equation 2x. So we plug 5 into g of x to get 2, and that 2 is now going to get plugged in to 2x to get 2 times 2, which gives us a final output of 4. So to summarize, f of g of 5 is equal to 4. Now, something I want to add to this is how this would look like with the alternative notation for composition. So, for instance, f of g of 5 can be rewritten to start things out as f of g of 5. And if you think about order of operations, this would tell us to maybe do the g of 5 first. And if we do g of 5 first, as we saw, that gives us 2. So the problem now boils down to finding f of 2, which, as we saw, gave us 4. One more thing that I want to show you, which can help to clarify the order in which we perform these function evaluations, is with a few arrows. So I'm going to go back up to this one where it says f of g of 5 equals 4. Basically what happens is you work from right to left in terms of how you evaluate the functions and which ones you use first. So if we wanted to plug 5 into this composition, it would first have to go into the function g of x, and then whatever comes out of that is going to have to go into the function f of x. And that's how we can think about the order in which we perform the composition. Alright, so that's where I'll end the video here. In the next one, we'll go ahead and do some composition function evaluations. Alright, in the meantime, if you have any questions for me whatsoever, feel free to let me know. Otherwise, thanks so much for watching.